Hello TaleForgers! At your request, I have prepared a tutorial about BadApple in Unity ECS. To begin with, what interesting topics will be covered? First, we'll focus on the quad spawner. The created matrix will be used for display. Second, we will create a system responsible for the logic. It will be system-based with managed component data. Of course, we will also create a shader, a prefab, a scene, and everything will communicate with each other, and this is where new things come in. So this tutorial will be a kind of summary of what has already appeared on the channel, as well as some new, I think, interesting things. So let's dive in and see how to create BadApple in ECS. Let's start with the code part. As you can see, I have created all the necessary files to just write code. You can pause video and also create empty files with class definitions. Let's start from BadAppleSpawnerComponentData script, change class to struct, and implement iComponentData interface. Of course, add using Unity.entities. Now we need to add 4 fields: public entity visualization, public int RenderTexture width, public int RenderTexture height, and public bool isSpawnComplete. There I created 2 classes, one for authoring and one for baker. As you can see in baker, I have derived from the baker BadAppleSpawnerAuthoring class and override the bake method. In the authoring we need to add 2 serialized fields. BadAppleVisualization, it is prefab, we will create it later, and RenderTexture. Of course, prepare getters for fields. In the baker class, we need to get entity with transferUsageFlag.none. Add component, entity, new BadAppleSpawnerComponentData, and pass parameters through the constructor initialization. Visualization equals getEntity SpawnerAuthoring.BadAppleVisualization transferUsageFlags.renderBoo. RenderBoo is enough because we don't need to move entity. And pass RenderTexture width and height. In BadAppleSpawnerSystem, I added burst compile attributes, change class to partial struct, and prepare onCreate, onUpdate, onDestroy, and empty BadAppleSpawnerJob. BadAppleSpawnerSystem implement iSystem, and BadAppleSpawnerJob implement iJob parallel 4. First, we want to get the singleton entity for BadAppleSpawner so that we can retrieve BadAppleSpawnerComponentData. Of course, add require for update. Then, check if the isSpawnComplete parameter is set to true. If so, return early. Now we need entity command buffer to handle spawn operations in job. So let's add private method entity command buffer.parallelWriter, get entity command buffer, ref system state, and inside var ECB singleton equals to system API.getSingleton and simulation entity command buffer system.singleton. Also add require for update and return ecb.singleton.create command buffer state.wordUnmanaged.asParallelWriter. Next, let's cache the texture width and height, as they will be useful for setting the array length for iJob parallel 4. Now let's implement BadAppleSpawnerJob. Add three public fields: public int RenderTexture width, public entity BadAppleVisualization, and public entity command buffer dot parallelwriter ECB parallelwriter. In the execute method, let's instantiate BadAppleVisualization. Remember to pass sort key. Then calculate row and column. Row equals to sort key modulo RenderTexture width, and column equals to sort key divided by RenderTexture width. Simple as that. Now set component via ECB parallelwriter, pass sort key, BadAppleVisualization entity, and new local transform. Position is equal to new float 3, row, column 0, rotation to quaternion identity, and set scale to 1. So go back to system and let's write job handle. Job handle equals new BadAppleSpawnerJob, open brackets, and pass RenderTexture width, visualization, and entity command buffer. Of course, schedule. Array length is equal to RenderTexture width multiplied by height. Batch count, let's set to 64. According to documentation, for simple job, you should set value between 32 and 128. And pass state.dependency so we can wait for job to complete. Don't forget to call jobHandle.complete. Set isSpawnComplete flag to true and set component via System API. Oh, I forgot to add BadAppleSpawner attribute to get entity command buffer. Alright, the entity spawner was successfully prepared. Now it's time to implement the logic responsible for the display. Let's move on to BadAppleComponentData, and note, this time we leave it as a class, as it will be managed component data. We implement iComponentData and create a public field RenderTexture. Let's move on to BadAppleAuthoring class. Let's create a serialized field RenderTexture and getter. In the baker, get entity with non-flag and add component object, pass entity as first parameter, and new BadAppleComponentData with authoring.renderTexture as second parameter. Okay, now we need to prepare new component data, which will define the float 4 value passed to the shader. So let's go to BadAppleVisualizationColorComponentData, change class to struct, implement iComponentData, and add public field float4 value. To make this work, we need to add a material property attribute with a name of our choosing. The field name must be identical in the shader we create next. Let's call this property BadAppleVisualizationColor. Let's leave the authoring class empty, then in the baker, get entity with transformUsageFlat.none, and let's add component BadAppleVisualizationColorComponentData to cached entity, which you can also write in the generic form, and it's fine. The last thing to implement in code is BadAppleSystem. In this system, I added BadAppleCompile attributes on create, on update, on destroy, and empty BadAppleJob. BadAppleSystem class derived from system base, and BadAppleJob implement iJob parallel 4. First, we need to create two variables: private entity query BadAppleVisualizationColorQuery and private entity query BadAppleQuery. Then assign queries in the onCreate method First query get all BadAppleVisualizationColor entities, and second get the BadApple singleton entity. We are using query to get singleton entity because BadAppleComponentData is managed type, so we can't use system API.getSingletonEntity. Now we need equivalent of the onEnable from monoBehavior. So let's create the onStartRunning method, and inside getSingletonEntity from BadAppleQuery, we need this entity to getComponentObject, our managedComponentData. Now we can write prepareFrameTexture and pass BadAppleComponentData.RenderTexture parameter. Of course, we want to create this method. There we prepare our texture2D instance. It has pass width, height, texture format. It is necessary to do this because, unfortunately, we can't work on the render texture to get needed data. According to the documentation, a render texture only has a data representation on the GPU, and you need to use texture2D.readPixels to transfer its contents to CPU memory. However, readPixels is very slow. That's why we want to read the texture async via async GPU readback. This is definitely a more efficient reading method. However, we will implement it in the updateFrameTexture method. Now focus on the prepareFrameTexture. Okay, let's go back to code. Let's create private texture2D field, currentFrameTexture, and in prepareFrameTexture, assign new texture2D BadAppleRenderTexture.width, BadAppleRenderTexture.height, textureFormat.RGB32 false. Don't forget to add BestCompile attribute. Now we need a reference to render texture during the updateFrameTexture method, which we will implement later. So in the onUpdate method, we can copy-paste code from onStartRunning, but without prepareFrameTexture. BadAppleComponentData contains this reference. Then let's create two native arrays to get BadAppleVisualizationColor, Entity Array, and ComponentData Array. Set allocator to TempJob. Now we want to call updateFrameTexture and pass RenderTexture from BadAppleComponentData. Create new method, private void updateFrameTexture with RenderTexture parameter. Of course, add BestCompile attribute. Inside this method, we need to set RenderTexture.active to RenderTexture parameter. Now what we care about is async fetch data from the GPU and set texture2D located on the CPU. So let's write async GPU.request pass RenderTexture. We can set MIP index to 0 and use lambda expression for async callback. Inside the lambda expression, we want to check if currentFrameTexture equals null. If so, return. It prevents error on application quit. Next, currentFrameTexture.setPixelData pass async callback.getDataByte, MIP level set to 0. Don't forget to apply changes to texture. You can also set RenderTexture.active to null. Great, we implemented the updateFrameTexture method, so let's go back to onUpdate. What's next? Get pixel data color 32 from currentFrameTexture and cache it into variable, pass 0 as MIP level. So it's time to implement job. We need to add two native arrays, which will have deallocate on job completion attributes. It has public native array entity, BadAppleVisualization entities, and public native array BadAppleVisualizationColorComponentData, BadAppleVisualizationColorComponentData array. Also public native array color32, BadApplePixels array, which we deallocate on the onUpdate due to the fact that allocator for getPixelData is set to temp. And of course, entityCommandBuffer.ParallelWriter ECB parallelWriter. Let's copy-paste getEntityCommandBuffer method from BadAppleSpawnerSystem plus remove ref_system_state state and change state to EntityManager. In the execute method, we retrieve current BadAppleVisualizationColorComponentData. Sort key is our index. Also get pixel from array and create new float for color pixel.r, pixel.g, pixel.b, pixel.a divided by 255 shader text values from 0 to 1. And I couldn't get the getPixelData method to take color instead of color32. Now, very important check. If BadAppleVisualizationColorComponentData.value.equals color, then return. This saves a lot of operations, especially in the case of white-black pixels. Let's assign BadAppleVisualizationColorComponentData.value with color. Then ECB parallelWriter.setComponent, sort key, BadAppleVisualization entities, pass sort key as index, BadAppleVisualizationColorComponentData. Okay, let's go back to onUpdate method and write jobHandle equals new BadAppleJob, pass all necessary parameters, BadAppleVisualization entities, BadAppleVisualizationColorComponentData array, pixels, and getEntityCommandBuffer. Don't forget to schedule the job, pass BadAppleVisualizationEntities.length as the first parameter, then set batch count to 64 and pass dependency. Wait for the job to finish with jobHandle.complete. After that, let's dispose pixels. Finally, we have our ECS code prepared. Now it's time to add a little counter and we can go straight to Unity. Set the text at the start to entities count texture width multiplied by texture height. Also add bold to text and remove unnecessary using. So let's go to Unity and create custom shader, right click, create, shader graph, URP, unlit shader, rename it to BadAppleVisualizationShader. Let's add a new vector4 field and name it BadAppleVisualizationColor as in the code. Then in Graph Inspector in Node Settings, check Override Property Declaration and change Shader Declaration to Hybrid per Instance. In the Graph Settings, change the surface type to Transparent so that we have access to the alpha channel. Now drag and drop to the field to create a node. Click on the output and use split node. Connect alpha output from split node to alpha input on the fragment node. Now let's pack the colors into vector3. Right click, create node, choose vector3 and connect inputs and output. That's it. Remember to save asset. Now let's prepare prefab. Create quad object on the scene, rename it to BadAppleVisualization, reset position to 0, 0, 0. Then add component to object, BadAppleVisualizationAuthoring. Disable cast shadows and remove mesh collider. In the mesh renderer, change material to BadAppleVisualizationShader. We don't need to create new material in this case because we don't have some settings to customize. Drag and drop to Project tab to make it prefab. Don't forget to remove it from scene. As you can see, I have an empty scene called BadApple. I need a render texture on which I will show the original video. So let's create a BadApple render texture, set width to 480 and height to 360. So it got 172,800 entities. You can set anti-aliasing value to 8 samples. Then let's create a new canvas. Select UI Scale mode to scale with screen size. Set reference resolution to Full HD. Match to width. Now right click on canvas, UI, raw image. Rename it to BadApple raw image. Adjust the position, anchor and size to suit your needs. And select the render texture we made before. Also create an entities counter. Add a new TextMesh Pro component, rename the object to BadAppleCounter, adjust position and size. Set font size to 60 and align to center. Add a script of the same name to it. Then pass necessary references. Now let's create video player. Right click, video, video player. Of course, set the video clip and the target texture to BadApple render texture. Next, let's create a camera. Change position to X equals 220, Y to 180, Z to -10. Also projection to orthographic with size 180. In the rendering tab, you can enable post-processing for temporal anti-aliasing, TAA. Set quality to very high. Disable occlusion culling and render shadows to minimize camera calculations. Also set background to solid color, white. Last thing to do, create ECS Subscene. Name it BadApple ECS. Inside Subscene, let's add two objects, BadApple and BadAppleSpawner. For BadApple, add BadAppleAuthoring component and select RenderTexture. For BadAppleSpawner, add BadAppleSpawnerAuthoring and select two parameters, Visualization and RenderTexture. Let's re-import the scene to see if we still get an error when we set the RenderTexture reference. Okay, let's test if it is working. Indeed, great job! I encourage you to support us on Patreon. Even a small contribution is a huge help in creating new content. Tier 2 also gives you access to code and assets. Link in the description. Thanks for your time. I hope you enjoyed the video and most importantly learned something useful. Take care and see you soon in the next video. And now enjoy BadApple.